Hello, my name is Chuck Dewey. I'm an R&D engineer here at Keysight Technologies. Today we will be talking about the X8712A solution and doing wired connectivity with it. In many cases, you will want to be doing wired connectivity for measuring the RF power so you can actually get accurate power measurements of your device under test. This way you can get a direct coupling of the RF power out of your device under test into the RF detector. Now, in this case, I also have a pairing device. This is connected to the second port of the solution. It does not matter which port you use for which device, but if you are using ports on these, they need to be 50 ohm loads or 50 ohm terminated at the end for accurate power measurements. The 20 dB attenuator on the pairing device makes it such that it's easy to pick out the RF signal from our device under test and our pairing device, so we can separate out those two different RF powered events so you can tell when the DUT is in transmission or the DUT is receiving data from the pairing device. So we will now go over to the computer and take a look at the RF signals coming in at the various levels so we can do triggering and analysis. Okay, here at the computer, what we'll do is we set our settings such that we have a fairly wide sample size and time interval so we can capture events to figure out the RF level. So what we'll do is we'll do an initial acquire in single mode to find the levels of both the DUT and the pairing device. In this first trigger, I only have the pairing device that has a transmission, so sometimes that happens and you will want to do an additional trigger to find these levels. Okay, here you can actually see where my DUT and my pairing device are doing a very good communication back and forth. Now, my DUT is actually coming out with plus 3 dBm, and my pairing device is down at about minus 20 dBm. So now what we want to do is we want to actually analyze the power during a transmit and receive cycle of this wired connection, so we can actually see the power levels and the current at the same time during receive and transmit. We've put the attenuator on the pairing device so we can separate these two out. So I will actually change my time down to 12 microseconds and lower my samples such that I am zoomed in a bit more to do the analysis. Then I will go down to set up the trigger. In this case, I know I'm running around plus 3 dBm, so I can actually set my trigger level up to 0 dBm. Now, the one thing you will probably want to do is have a slight offset in your analysis so you have some pre-trigger. This way you can see the events leading up to the RF event. In this case, I've set it for minus 2 milliseconds. This will give me a good measure of the events leading up to this RF event. So now I will do an acquire, and here you can actually see a very good event. So you have the pairing device right here at minus 20 dBm, and you have the DUT at +3. You can see during this time, the DUT is using 458 milliamps during this time, and during the receive period where the pairing device is transmitting, you can see it's using 158 milliamps. So you can actually separate the DUT transmission from the pairing device transmission by using this technique. Thank you. This was a video demonstrating wired connections with the X8712A solution.